Welcome to Demystifying Math. In this lesson, we're going to be graphing the sine function. Specifically, we're going to be working on graphing combinations of different transformations of the graph. This is part 4 in a video series on graphing the sine function. In the previous videos, we saw things like an amplitude change, where the sine function is multiplied by a number. In this case, we're using the letter A to represent that number. This will cause a vertical stretch or shrink of the graph. If A is a negative, it will additionally flip the function over the x-axis. If x is multiplied by a number, it's going to cause a period change of the graph. To find the new period, you're going to divide 2 pi by the coefficient of x, or by b. This will cause a horizontal stretch or shrink of the graph. You might also have a horizontal shift of the graph, moving it left or right. This is called a phase shift. And that's going to happen when you have a number subtracted or added to the x value. In this case, we have c as a number that's subtracted from it. But the b value, the period, will also affect it because they're both horizontal movements. So you're going to find your phase shift by dividing c by b. Sometimes it's easier to go ahead and factor out the b, and then you can see what your phase shift is easily. Also, the c is negative in front of it, which means that the shift is going to go in the opposite direction of the sine. Then the other type of transformation you might have is a vertical shift, moving the graph up or down. When a number is added or subtracted from sine, then it's going to cause a vertical shift. Okay, so we want to concentrate on some combinations of the transformations. In this case, we have the equation y equals 1/2 times sine of 3x. Let's first discuss what our transformations are. In this case, we do have a number that's multiplied by the sine, and that 1/2 is going to cause an amplitude change. Instead of having our lowest points at -1 and our high point at +1, they're going to be at -1/2 and +1/2, which cause a vertical shrink of our graph. In other words, the graph is going to be closer to the x-axis. It also has a number multiplied by x, and that number is going to cause a period change. We can find our new period by dividing 2 pi by 3. There is no phase shift, so it didn't move left or right at all, and there's no vertical shift, so it's not moving up or down. Okay, so we want to go ahead and graph it. And our first step is to take our period and divide it by 4. This is going to tell us how often a critical point will occur in our graph. Our new period is 2 pi over 3, and dividing that by 4, or multiplying by 1/4, we get pi over 6. Just make sure you're always putting it in lowest terms. Then our second step is to find our starting point. Since there is no phase shift in this case, our starting point is going to start at 0. Then that's going to be our first critical point. To find the following critical points, all you do is take the period divided by 4, which we found in step 1, and add it to the previous critical point. So we're going to start at 0 and add pi over 6 to that. So our next critical point is going to be at pi over 6. Then continually add pi over 6 until you get 5 critical points. So we get 2 pi over 6, 3 pi over 6, and 4 pi over 6. If you need more critical points, just keep adding pi over 6 to it. Now what you want to do is take all those critical points and put them in lowest terms. So you have 0, pi over 6. The 2 pi over 6 becomes 3 pi over 3. The 3 pi over 6 becomes pi over 2. And 4 pi over 6 is the same as 2 pi over 3. Now that you have your critical values, these are x values. You want to do is take them and plug them into the function to get out your y values so you can plot your points. So starting with 0, well, 3 times 0 is 0, and the sine of 0 is 0. So we end up with a 0, 0 ordered pair. That's a critical point. Okay, now we want to plug in pi over 6. So we're going to multiply it by 3 first, and we get out pi over 2. The sine of pi over 2 is 1, so 1/2 is our output. So that gives us another ordered pair at pi over 6 and 1/2. Remember we said that there was an amplitude change here, so your highest point is going to be at 1/2, your lowest point is going to be at negative 1/2. Okay, plugging in pi over 3, we're going to multiply by 3 first, which gives us pi. The sine of pi is 0, so our output is 0. Next, we're going to plug in pi over 2, so that simplifies to the sine of 3 pi over 2, and that's negative 1. So our low point's at negative 1/2, as we expected. And then we're going to plug in 2 pi over 3. Multiplying by 3 first gives us 2 pi. So we're back to 0 again, which we expected. So when you get these critical points this way, you're always going to end up with those 4 critical points, or 5 critical points that were on the unit circle. Alright, so now that you have these critical values and your ordered pairs, what you want to do is plot them and draw your graph. Alright, so plot your ordered pairs and sketch your curve, and you should get something that looks like what I have here. So check your work and make sure you're doing it correctly. Okay, let's try another one. We're given the sine of 2x minus pi over 4. This one does have a phase shift. So the first thing I'm going to do is factor out the 2 so I can easily see what my phase shift is. So I end up with 2 times x minus pi over 8. The amplitude is 1. The sine is not multiplied by anything, so it's just going to be a 1. The period is 2 pi divided by the coefficient of x, so we end up with a period of pi. Our phase shift, since we factored out the 2, we can easily see that our phase shift is pi over 8. Since it's subtracted, we're going to go in the opposite direction, so we're shifting pi over 8 in the positive direction. And there is no vertical shift on this graph. We're going to follow the same process we did on the previous one. We're going to figure out how often a critical point occurs by taking our period and dividing it into 4 equal parts. Then we're going to look for our starting point. Since this one does have a phase shift, the starting point is going to be what your phase shift is. So it's going to be at pi over 8. That's your first critical point. Now what we want to do is continually add 1/4 of the period to a critical point to get the next critical point. So we're going to start at pi over 8 and add pi over 4 to it, which is really the same as adding 2 pi over 8. So we got 3 pi over 8. Now we're going to add another 2 pi over 8, and that'll give us 5 pi over 8. And then continually add 2 pi over 8 to get all of your critical values. In this case, they're already in the lowest terms possible, so all we have to do is list out what our critical values are. Now that you have these critical values, which are x coordinates, we want to find the y coordinate. So we're going to plug them into the function. Now you should probably already have an idea what your outputs are going to be, but let's check it. So we're going to plug in pi over 8, subtracting from that minus pi over 8 is going to give us 0. So we have the sine of 0. Plugging in 3 pi over 8, it reduces down to pi over 2, so we get out a 1. The next one should give us a 0 if we follow the pattern of a normal sine curve, and it does. And then I guess you could imagine what 7 pi over 8 will give you, and 9 pi over 8. So you get the same pattern as output values as we had before. Okay, so now what you're going to do is plot those ordered pairs and then connect your graph using a smooth curve. So take a few minutes and do that, and then come back to the video. Check your work to make sure that you've plotted your graph correctly. Okay, let's try one more. We have 3 times the sine of 1/2 x minus pi over 6. In this case, we do have a new amplitude of 3. We have a period change of 2 pi divided by 1/2, which is the same as 2 pi times 2. So our new period is 4 pi. We also have a phase shift of pi over 3. And I got that by factoring out the 1/2 first and then I could see what my phase shift is. Or you could do pi over 6 divided by 1/2. And we do not have a vertical shift in this case. Okay, so our period is going to, our period divided by 4 is going to tell us how often our critical points occur. So since our period was 4 pi, dividing it by 4 is going to give us pi. So every pi units, we're going to have a critical point. Now we're going to find our starting point. In this case, our phase shift is pi over 3 to the right, so it's going to be at pi over 3. And then we're going to take pi over 3 and add pi to it. And that's going to give us 4 pi over 3. Well, adding pi is the same as adding 3 pi over 3. So the next one's going to be at 7 pi over 3. Then continually add the 3 pi over 3 until you get all your critical points. And if you need to, put them in lowest terms, but these are already in lowest terms. Now that you have all your critical values, you're going to plug them into the function, and hopefully you're going to know what to get out, because our amplitude is 3, our highest point is going to be at 3, and our lowest at -3. In this case, there's no vertical shift, so it's just going to be at 3 and -3. So plug them in. At pi over 3, we end up with 0. At 4 pi over 3, we got out 3, which we expect. Always check them to make sure that you got the right critical values. But if you're pretty confident in your work, you can probably finish up the rest of them pretty easily. And you have your critical points. Okay, so go ahead and plot them and connect your graph with a smooth curve. And you should get something that looks like this one. Check your work and make sure you're doing them correctly. Thank you for tuning in to Demystifying Math.